I'm an engineer on Google+, and I'll be talking about the work we're doing with CSS modules. For those who have already seen this at CSSConf, sorry, this is basically the same talk. I updated a few things based on questions from there. So the problem that CSS modules is trying to solve is not a problem that's unique to Google+ or Google. It's a problem of all very large applications. This is just a sampling of some of the top-level pages. And within each of these pages, we have lots of features. And that adds up to lots of JavaScript and CSS. And as you can see from these numbers here, we have a ton of CSS, and we have a problem to solve. The other problem that module system addresses is a problem that almost everybody struggles with, which is writing maintainable CSS. And we have both of these problems in Google+. A lot of CSS, too big, too slow. And since we are manually curating our CSS in our build files, it's brittle and prone to reordering when developers refactor their code. So this has resulted in many broken UI regressions in our QA. And because developers cannot rely on a deterministic cascade order, they have to resort to things like specificity, which gets ugly. So this talk is about the module system that we've developed, with the primary goal being CSS size, initial load time. Building a module system is a lot more straightforward if you have absolutely no shared code at all. Let's say we didn't share any code between our pages on Google+. Then you could simply make each page a module and download it, and it's much more straightforward. But in reality, we have a lot of shared styles. And if you don't have a lot of shared styles on your site, you're doing something wrong. So we had to develop a dependency system to handle this. And that itself has been a huge win. And it's really improved developer productivity, because now our developers can rely on this deterministic cascade and not be fighting specificity. So we haven't launched this module system fully to our entire site. We have launched it to some pages. And we've seen significant performance improvement in terms of CSS size. The CSS preprocessor we use internally is called Closure Style Sheets, and we call it GSS internally. So if I say GSS in this presentation, I really mean CSS. So we've said that we have shared code, we want a dependency system, but to build an effective dependency system, you have to know what the shared code is. And this is not always obvious for a really large site. You might notice that there is some similarity between a button and a menu item, but it's not obvious what those are. But you can start with the obvious. There are a lot of repeating UI elements in a lot of sites, and we have a ton of these. And these are things like buttons, icons, or what's called the media object, with image on the left, text on the right. So Google+ is a social network. The primary content on the main page are posts from people in your network. And every post is contained in its card. And every post has the same characteristics. The circular icon with the person posting. There are buttons for for upvoting and resharing. There's comment activity. And on the left-hand side, there's a box that you would start typing in if you wanted to share something with your network. And we call this the share box. So this is a completely different page. It's my profile page. And it's got this unique element on the top right going. But the rest of the page is looking very similar. There are posts. The posts have the same characteristics, same components. And again, there is a share box. Another page on our site, community page. And it has a description of the community in the top right card. And there's a panel on the left. But the rest of the page is, again, posts and the share box. Yet another page, photos. And this looks very different at first. But then if you look on the right panel, you see the same recurring UI elements. So you get the point. We have a ton of shared components across our entire site. But this is not everything in terms of shared styles. In addition to this, we have fonts and colors that we share across all of Google+. And in addition to that, we have lots of shared styles across all of Google. And these are for things like buttons, checkboxes, menus, toolbars, et cetera, so that as you're visiting different Google properties, like search or maps, you have a somewhat consistent look and feel. So now we have these somewhat competing goals, because our developers want to split all of this code by project boundary, because all of those features I showed you, the home page, the profile page, photos, they're all developed by completely different teams. But we, the infrastructure people, want them to share all of these common styles. So this is all the more reason we need a dependency system. We need a systematic way for them to be able to reuse all this code. We cannot just depend on developer discipline. So let's take the example of the homepage and the community page. We know that they both need to render posts, they both need to render a share box, and so they have some common code for that. In addition to that, they have unique UI elements for their own pages. But for this common code, we want them to be able to write this only once, download it only once to the browser, and download only the minimum code they need. So let's step back from CSS and consider all of the code needed to render one of these pages. So for the home page, we know we need templates, JavaScript, and CSS, everything that the browser needs to render this page. So for the home page, we know we need to render posts, share box, and other homepage-specific elements. So one goal here is we want our initial page to be super fast. We want to download only the minimum needed when we visit the home page. And later on, when we visit another page, like the community page, just download the incremental code needed for that and nothing more. So there is a solution for this in JavaScript, and it's called JS modules. And it solves exactly this problem of incremental download. And examples familiar to JavaScript developers would be AMD, CommonJS. And last year at JSConf, my coworkers, Malta and John, unveiled the Google open source module server. However, there is no solution here for CSS. And the question is, can we use the same solution? So there is a catch in CSS, which is safety. So let's say you visited the home page and then you visit the community page. If you're not careful about how you write your CSS, you could potentially override the styles of the home page and distort that page. So for example, if there was a button with the same selector on both sides, and the community page added styles to the same selector, and now your home page button is broken. So now an additional goal we have for CSS is that we want absolutely no UI regressions on the previous page as you visit new pages. So we're starting to see that CSS is not so simple. The challenges here include the safety issue that I just mentioned. In addition to that, we know we have all of these shared depths, and we need a dependency system, but there is no notion of dependencies in CSS. And almost every other language seems to have a dependency system. And this is like require in CommonJS, or import of Java and Python. So then the question is, how do we depend on what we need? And how do we depend on only what we need? So we recap our goal here as we want to deliver the minimum amount of CSS. We want to do it incrementally and safely. And the challenges are bundling the CSS with its dependencies, downloading it as needed, and safely composing it. So we're really saying what we want is a module system. We want a dependency system so we can bundle all the CSS with its depths. We want an assembly and serving system so we can download it and safely compose it. So let's consider each of these challenges, starting with the bundling. So we define a module as a bundle of CSS. It supports a page of our site, download it together. And we already identified some of our CSS dependencies as the shared code. This is CSS that comes from shared components, from things like shared fonts and colors, and the common CSS libraries. In our case, these are typically the Google-wide style libraries. So before we dive into our solution, let's rule out the naive solutions that don't work for us. We cannot just, we don't want duplication, so we can't just add an additional CSS at import in every page and duplicately download all of those shared styles. You've already seen we have a ton of shared styles. We want to include only what we need. So if there are like 7 variants of the share box widget, and if my page just wants to depend on one of them, I want to include just that and nothing else. In addition, we don't want to take every single style that's ever shared across our entire site and bundle it together in a single shared depths module, because this is very quickly going to become very big and very unmaintainable. So starting with dependencies, we know the first type of dependencies are shared components, and we have a bunch of these. But what is the CSS that we need for these? It's not easy to tell because we are writing our styles in a separate style sheet. But we do know what templates we need, and we do know what JavaScript we need. And these, in turn, can point us to the CSS that they need. So essentially, if we associate the CSS with the JavaScript and with the template and create a component, then the CSS can just come along when we depend on this component. And this is similar to the idea of CSS Legos. That's fairly well known in the CSS community, where you identify bundles of CSS for reusable widgets. The new concept here is we wanted to be self-contained. We wanted to include its templates and its JavaScript. And this lets us have the framework do all the heavy lifting, and we're not relying on developer discipline. So we've said that we want to have dependencies from template to CSS and from JavaScript to CSS. So we've created our own custom syntax for this. We use closure templates on Google+, and so we've created a require CSS syntax that just gets added to the template, and it points to the namespace of the CSS that it needs. In addition, we've created a syntax in JavaScript, which is an annotation that, again, points to the CSS namespace that it needs. And this can just as well be expressed with AMD syntax. So once we do this bundling of components and pointing to components from these widgets, we essentially end up with a component dependency graph, something that looks like this. And this thing can extend to our entire site. So we have a complete component dependency graph across our site. So the next category of dependencies are things like fonts and colors and layout things that can be expressed as constants and mixins. So there is pretty standard syntax for this in most CSS preprocessors. And this is the ent-import directive in Sass. We use closure style sheets in Google+, and our syntax is called @provide and @require. So let's say you have some CSS namespace called profile base, and it's exporting a constant called profile update background color or something. And then you have some other CSS that wants to use this constant in a style. All it has to do is @require profile base namespace. And this notion of fonts and colors and constants expressed in namespaces maps well to our CSS dependency graph. So if you have constants that are applicable only to the photos page, only the photos page will depend on these. And then if you have other common constants that are needed by multiple pages, then they can all depend on those. We still haven't talked about shared CSS libraries yet, and we'll come back to that in a minute. So moving on to the next challenge, which is safely composing CSS in the browser. So before I delve too much into safety, I feel like I need to set the background here with kind of the core concepts of CSS, which are order and specificity. The C in CSS is for cascade. CSS is inherently order dependent. If you have base styles and you have overrides, the base styles must be ordered before the overrides. And specificity can trump order. So let's say I have a text, hello world, wrapped in a div, and it has two classes, blue and red, with the colors blue and red. The color of this text is going to be blue. And the reason for this is that it is the cascade order that dictates styles and not HTML. I continue to see developers be confused by this because this is not intuitive. So now if I add an additional class called hello in the same tag, and I update my red selector to hello.red, and now the text is red. And this is because I have just bumped up the specificity of the color red. This is generally not a great way to do overrides, because you can get into trouble when you want to, again, override this. So the next time you want to override again, you're basically fighting the previous specificity, and which is why this is famously called the specificity wars. So the basic rules are, as much as possible, we want to use the cascade to dictate styles and not specificity. There is a known body of work, thanks to the work done by Nicole Solomon on object-oriented CSS. There are some basic guidelines, and we have found these to be fairly accurate in our own experience in Google+. And the guidelines are minimize your selectors, reuse as much as possible, simplify specificity, should be as low as possible, and keep your rules to have the same strength. Use the cascade to override styles, not specificity. So really, what we want is a framework that enables us to basically allows us to develop using these guidelines. It should enable simple selectors. It should enable rules of equal strength. And ideally, the framework itself should order the cascade correctly, so we, the developers, don't have to worry about specificity. So let's consider the concrete example of overrides for a button. Let's say we have a button. It has some shared styles. And we have different pages on our site that want to style this slightly differently. For the sake of this example, let's say each of these pages wants a different color. So there's many ways for overriding styles in CSS. And this is a list of them. And there's pros and cons. So we're going to take a quick tour of these examples. So the standard way to do this is you want to extend the base button styles with your context-specific styles. So in this case, say you would add a profile button class. And then you might use a compound selector, like profile button.standard button. And we've already said why this is not the ideal practice, because this is prone to clashes. Now let's say the profile page again wants to override the button in its context. If the button appears on the header versus sidebar, it should look differently. And that's when you start getting into trouble here. Another way to do this is using descendant selectors. So you would say profile post space.standard button. And the problem with this is now you are tying your CSS to a predefined HTML structure. You could use tools to do this. And most CSS preprocessors have the notion of mixins. So if you use a mixin here and expanded that, it would essentially put the styles in line in the profile context and the event context. And the nice thing about this is that now you no longer need the standard button. But on the flip side, this is a lot of duplication. This is not going to scale for our site. Another possibility is using the Sass at extend directive. So you would create a placeholder standard button, and then you would extend that in the profile context and in the event context. And this compiles to something like this, where Sass will create a single rule with all the shared styles. And this is much better now, much better than mixins. You no longer have the duplication problem. But now there is a single selector for each of these. And in our case, when we have this big CSS dependency graph, this selector is going to this rule is going to show up in a shared module in our graph. And ideally, for our dependency graph, we want to keep context-specific and feature-specific selectors in their own modules. So finally, one way to do this is simply add an additional class. Keep the standard button, and just add more context-specific selectors with the overrides. But here, now you have to rely on the correct CSS cascade order. This is, in fact, our preferred solution for what we do in Google+. And we let the framework order the cascade correctly using @require. So in this case, when the profile button wants to be ordered after the standard button, all it has to do is @require the standard button. So we essentially now expanding the semantics of @require to include ordering. And we've considered some alternatives here, like expressing this ordering in our JavaScript or in our templates, but that starts to look awkward. And we like this approach because it meets our requirements. It minimizes the number of selectors, and now we have rules of equal strength. So we still haven't looked at how we do overrides and components. The example we just looked at was the case where we have a shared library of styles, and we had some shared button styles. What do we do about shared components? So let's say you have an icon component that's used in multiple contexts. Like many widgets want to use that same icon, but they want to override it and have it look slightly differently in each context. So when we create a component dependency graph, the nodes in the graph will have the bundled template and the JavaScript and the CSS for this. And then later on, we essentially flatten this dependency graph to the cascade, but we preserve order when we do that. So now you can see why the cascade order is correct. And so now we have styles that show up in the right order. and that's great. We still haven't said how we are overriding. So we typically either use additional classes or descendant selectors. Additional classes require you to plumb your new class down to the components template. But if the component is going to be overridden in almost every context it's used in, then that's actually better because it exposes sort of an API. The other way to do this is use a descendant selector. And here, we're not tying it to the HTML structure per se. We are tying it to each context that the different pages need. All right, so far, we've covered the types of CSS dependencies we have. It's components, constants, and mixins, and libraries. And we've looked at the dependency syntax in each category, and we've looked at how style overrides happen, and we've demonstrated that the cascade order is correct. So with the addition of the shared CSS libraries, now we have a complete CSS dependency graph for our site. Oh, and by the way, we don't just rely on developers to do the right thing here in terms of adding the dependency syntax. We actually do enforce it. And this is using tools and tests and compiler passes. So for require CSS, we have tests that create maps out of the CSS namespace classes, and the test will fail if you're missing a require CSS, basically. And similarly, for the @require, we have compiler passes that enforce some things. Like you cannot simply keep overriding the same selector in multiple contexts. Like you can't just say .foo and then again .foo, and et cetera. Also, we want to enforce the ordering of classes in the HTML. So that goes back to our original Hello World example. Like you'll be forced to express that ordering with @require. All right, so far we've covered the dependency system part of our module system. We've looked at namespaces. We've looked at how we express dependencies using require CSS and @require. So now we move on to assembly and serving. So I touched on this a little bit earlier, how we have a dependency graph and how that gets flattened to a cascade. The additional thing here to note is that nodes in this, like bundles of nodes in this graph, get compiled to modules. And those modules get ordered correctly. A module is a group of CSS that's downloaded together. And we always make sure that the shared dependencies are downloaded with the first module that needs it. And we have analogous JavaScript modules for our CSS modules. So the two requirements of a serving system that we really want, we want to minimize the number of requests, and we want cacheable responses. So one thing to note here is that the client has the knowledge of the dependency graph. So it can ask for the modules that are needed. So let's say you're on the first page on Google+, let's say the community page, and you make a request to the server. You're essentially constructing a request URL that has the list of modules that you need to show that page. And then on the server, the list of modules gets concatenated down to a single response. And so you're serving a single response. And again, the next page, if you go visit another page, because you have state on the client that knows what modules have already been requested and cached, you only request the additional modules on the next round. And one thing to note here is that this addresses our original problem of safety. We don't get into the problem of, oh, I'm on my next page, and the new styles of the community page are killing my button. That doesn't happen because we've already done the hard work of creating this dependency graph. We've identified the shared styles. We've extracted them out into the depths. So always the depths are present beforehand. So now this solves our problem, our original problems of Google+, which is big CSS bundles that's slow, and specificity wars, manual curation, maintainability. So these are some open source resources that you can look at. We use closure style sheets, which has our @provide and @require syntax. And we use closure templates, which doesn't have our require CSS syntax yet, but will in the future. Thank you. That's all.
Thank you, Shubhie. Do we have questions?
Hi, Shubhie. So Going back a bit to the performance you mentioned, you just want to download the additional CSS that the page needs. How about cacheability of URLs? How do you tackle them? Do you just add more URLs that the browser has to cache, and do you like proliferate a lot of URLs that in style sheets that the browser caches with this approach?
So, like I said, we are caching the previously downloaded modules. So the next URL will not have the modules that you already downloaded before. So you basically get caching, and you only get the incremental modules you need on the next run.
Right. So that's a separate request, you mean?
Yes. So the next request will have the additional modules, and so on. And if you go to another page, you won't get you already cached modules from the first 2 pages, and now you'll only get additional stuff for the 3rd page, and so on.
Yes, sorry.
Hello, Shubhie. I want to thank you for your presentation.
Thank you.
I work for Yandex. It's kind of Russian Google. Maybe you heard of it. And actually, I work at a team which are responsible for quite similar thing. We created methodology and tools and some libraries which provide almost the same ideas to reuse blocks and to share same components among all our services. We have about, I think, 200 of them. And I have got a question. Right now, you said that you share a lot of same components, but all of them are in Google Plus, just one service. But I'm sure that quite a lot of different services at Google uses the same things. And are you going to share your same components among all the services? And if so, how would you do it?
Yeah, so we actually do that already. So things like the +1 button and stuff, they show up in multiple, all over Google, and like on search and stuff. So we're already doing that. So we do have a shared, well, we're still sort of pushing towards sort of, making them as encapsulated and kind of bundled as possible. But we do have some of these, like the +1 button that has, templates and JavaScript and CSS, and now many different things can point to that.
But my question is a bit wider, I think, because I'm sure that different services uses different technologies for templating, writing JavaScript with different approaches and so on. And it's not so easy to share same components among them.
Yeah, that's absolutely a problem, right? So if Maps is using a completely different templating system, then yes, that does break down there. They cannot just use the entire component. They can only use the styles and the JavaScript and import that. So yes, we haven't solved that yet.
But still, you're going to try. And if so, I think we can share our ideas, and maybe we can borrow something from you.
Absolutely. I'll have to chat later, for sure.
I think we can find a lot of helpful things between our approaches and combine our efforts.
Cool.
Thanks. Thank you very much.
All right. If that's it, thank you so much, Shubhie.